Hello everyone, this is the sixth video on our bonding series and we're looking at intermolecular forces now. By the way, the full video is on YouTube at Copy Chemistry, so just search it, you'll find the full video there. Okay, so intermolecular forces, we have said that they are divided into the hydrogen bonding. That's the first one, hydrogen bonding. And also we have the van der Waals forces. Yes, but today we're going to be looking at the hydrogen bonding. And the hydrogen bonding is the strongest of the intermolecular forces, okay? So it's actually strong. It happens when hydrogen bonds with electronegative species. So when you have hydrogen bonding with something that is very electronegative, then that will be a hydrogen bond. Alright, so an example is fluorine. Hydrogen can also bond with oxygen, and hydrogen can also bond with nitrogen. These are hydrogen bonds. So if you see a compound like ethanol or water, H2O, where you have OH bond present, it means that if you have different molecules, more molecules of that particular compound, you could have hydrogen bonding present there, okay? You could also have hydrogen bonding present in ammonia molecules. That's because there is an NH bond here, right? There's also an NH bond here. So you could have that interaction. In water molecules as well, different water molecules, you could have hydrogen bonding present. In hydrogen fluoride molecules as well, you could also have hydrogen bonding present there. So now let's see how the hydrogen bonding is present in HF, okay, which is your hydrogen fluoride. But before we do that, I would just like to reiterate that hydrogen bonding occurs when hydrogen is bonded to very electronegative atoms like these ones here. These are the major ones. They are very electronegative. Fluorine is like the most electronegative element on the periodic table. Okay, this has a value of around 4.0, followed by this one around 3.5, and this around 3.0. Their electronegativity values, they are the highest on the periodic table. Okay, so you do not have to remember the values, you just need to remember that the fluorine, oxygen, nitrogen, they are highly electronegative, thus hydrogen bonding could be present there. Now let's see how the hydrogen bonding actually plays out in HF. And here is our HF. And then we could have another molecule of HF too, like this. It could be here that this is a partial positive charge and this is a partial negative charge, right? It could now be, because this is very polar, this is also a partial positive and this is a partial negative. Your fluorine here, which is partial negative, can attract to the hydrogen here, which is partially positive, such that it generates this bond here, and that's what we call the hydrogen bond. So you could continue, have another HF again, what could happen? Hydrogen bond here like that, right? So that is basically how it works. So that holds this molecule with this other molecule, and that's what we're talking about. So we can also see that play out in our H2O, that's water molecule. So for H2O, H2O is this way, but of course this is partially positive and this is partially negative, right? Another H2O molecule like this, partially positive, partially negative. So what are we doing here? From the positive to the negative, right? So we have something like this, and this bond here is the hydrogen bond. So that's what happens. Very interesting. So this is what happens in your hydrogen bonding. It is the strongest intermolecular force. Alright? the strongest type of it. Okay, so that is basically that. The next one on our list is the dipole-dipole interaction as well as the London forces, which are the van der Waals forces. Okay, so please watch the next video, that's video 7, because we're going to be talking about that. Alright, see you. Bye.